Great. So, see, I have some notes because I want to make sure I say all the great things about Jessie Olson. I'm really excited to introduce Jessie Olson today as she's the Habitat Restoration Director at Save the Bay. And she leads their Bay-wide partner-driven community-based restoration program. And I'm super privileged that I got to work with Jessie for about 5 years when we overlapped at Save the Bay and got to watch her develop the amazing nursery program and expand the restoration work that Save the Bay does. So during the time she's been at Save the Bay for 10 years and has changed how Save the Bay approaches large scale projects like the one you'll hear about today. She's grown the scope and size of not only the nursery work, but the restoration program as well. So today she's going to share some of her work at the Ravenswood complex where she works in partnership with us on the South Bay Salt Pond Restoration Project and with the U.S. Fish and Wildlife Service. So she has some exciting photos and some exciting results to share with us today. So before you start, I just want to ask the audience to put any questions in the chat and we'll answer them at the end and any other questions that you have then. So Jessie, take it away.
All right. Thank you so much, Donna and Dave and the South Bay Salt Pond Restoration Project. I appreciate being invited to speak as part of this series. I've really enjoyed our recent past presentations. Folks like Maddie Schwartz, who I see in the field monitoring Western snowy plover at some of the sites that we share together, getting the opportunity to hear her talk about her work over Zoom and learn more in detail than just waving from like standing in the field to a truck. These have been really fantastic, and I'm honored to be part of the cohort here. I'm going to speak today a little bit about Save the Bay's recent efforts revegetating a couple of habitat transition zones as part of the Ravenswood complex. And this work includes new methods that have deviated from some of our previous work conducting smaller scale community-based restoration around the Bay for the past 25 years now. We're actually celebrating our 25th year of our volunteer program in 2025. So something we're excited about and proud of. All right. As I mentioned, we have a long history of community-based restoration around the Bay. One of our primary focuses is serving as a connector between the science and policy that's happening in our area and to members of the public who might not know much about it. And we do that through our volunteer program out on the shoreline. While restoration is certainly the focus of our effort, we've challenged ourselves in the last couple of years to work on pilot projects and contribute to some of the ambitious goals that our region is trying to meet. We do that through projects like the Oraloma Horizontal Levee Demonstration Project, which we worked on between 2014 and 2016. Current iterations of that multi-benefit nature-based solution are in the planning and design process now. But what is especially relevant to this work that we've done at Ravenswood is the way that we approached bulk propagation and revegetation. For that project, we also grew tens of thousands of native locally collected propagules in an abbreviated timeline. And we tested new methods there that we've taken with us moving forward. And then on projects like this one, we've added even more new methods, trying to scale up that work. So for many of these larger projects, like the Ravenswood complex work, we're thinking less of these sites as like tending to a native plant garden, and more of how can we disperse as much native vegetation across these habitat transition zones as possible and on a landscape scale. The two habitat restoration sites that we're talking about as part of the South Bay Salt Pond Restoration Project are on this map here. They total approximately 25 acres. On the upper left, we have what we internally call the Bedwell Bayfront Levee. The first year of planting, Save the Bay, started in the fall of 2021. And then the second of the two levees is the All-American Canal here, the lower and larger of the two levees. The first year of planting for us was in fall of 2023. One thing to note about this site for anybody that might not be familiar, although I'm sure many people on this call are, is that the green pond here in the center of the map, the R4 pond, was breached to the tide in December 2023. So right in the middle of the work that we were doing on these habitat transition zones. And we used the same revegetation methods for both of these sites. So I'll be speaking about the two sites almost interchangeably throughout this presentation, and know that the methods were similar between the two, even though they were sequenced back to back. To ramp up our propagation for this project, we constructed an on-site division bed nursery. This is a strategy we've employed before. We used it at the Oraloma Horizontal Levee Demonstration Project. And we found this strategy to be instrumental in reducing the travel and labor between a nursery and a restoration site. We have two traditional container plant nurseries that help us do our revegetation work, one in Oakland and one in Palo Alto. And there's a significant amount of driving that happens as part of our work anyways. But for a project of this scale, we found it to be helpful, if possible, to create that nursery as close to the project site. The West Bay Sanitary District generously and temporarily lent us a small parcel of land on their property, which is adjacent to Bedwell Bayfront Park and to the restoration site. On that site, we built 84 division beds and connected those division bed sites to a municipal water line via a drip line. We were able to irrigate the division beds using a timer so that we didn't have to have a staff member or several out there hand watering the division beds every day. We were also able to really reduce the amount of irrigation that we were using across the site and limit it to only right on top of the plants. So we felt good about that as well. All of the plants that were in the division beds were rhizomatous for the most part and perennial and collected from local populations in the South Bay. Some beautiful plant images, if you like that. The native species selected for the project were based on an original memorandum by Peter Bay, an incredibly knowledgeable consulting ecologist who worked with us on the project. It split the native plant species into 4 functional groups, which we treated differently for our purposes in the propagation and planting process. We relied very heavily on clonal meadow species like creeping wild rye, saltgrass, and western ragweed, which we knew were tolerant of mistreatment, disturbance, and some drought-like conditions. Additionally, we included native species in what we called the diversity patch and refuge patch functional groups. These species might be less tolerant of that abuse in the planting process, but they also provided additional benefits like biodiversity, pollinator resources, and perhaps more substantial high tide refugia in the case of some species. And our final functional group was an annual native cover crop. We included this as a means of temporarily outcompeting some of the non-native or invasive species that we knew were already on the site. And we were very intentional on which species we included as part of that seed mix to try as best as we could to align them with the life cycles of some of the non-native species that we knew were there. To get like a little specific with species, like an example of this would be including fiddleneck, which is an early spring annual intended to outcompete European mustard and sweet clover, to spring non-native annuals that we knew were out on the site. And similarly, we included a lot of coast tarweed and hayfield tarweed, which are annual species that bloom and take up space in the summer and early fall, to outcompete some of the natives that shared that similar life cycle, like Russian thistle and stinkwort, 2 of which we already knew were in the general area and might pop up on the habitat transition zone slope. We followed a pretty regimented schedule for our outplanting process throughout the course of the year. This is sort of a wordy slide. I was joking earlier. I know that wordy slides are unappealing. I don't necessarily need you to read it, but a couple of things that I do want to make sure I note about our schedule is that we intentionally designed the timing so that the bulk of our revegetation effort happened prior to the onset of the seasonal rainy season. There were many reasons for that. The first of which is that it would be wild to knowingly drive a tractor into mud. And so we were using heavy equipment to do a lot of this work. We didn't want to end up in a situation where we were pulling heavy equipment out of a tidal marsh or out of that habitat transition zone. So logistics made sense in timing it prior to the onset of rain. And then we were also particular about the annual seed mix and ensuring that that annual seed mix germinated on time with how the non-native annuals were germinating. We've had experience in the past where we don't time that perfectly, and we don't get the same germination from the annual seed mix. The timing of this is particular and is tricky, but we've tweaked it over time from our work on past large-scale projects and from using methods like the annual seed mix cover crop and planting dormant rhizomatous species. So in October, we began the process of preparing the site and also preparing the sod material for translocation to the site. Prior to planting on the slope, we had a partner disc to eliminate the invasive species cover and reduce compaction from grading. Unfortunately, COVID-related project delays allowed a couple of invasive species to start germinating on the site, but it was a very quick remedy with just a pass over through with the tractor. And then for our nursery site earlier in the summer, we gradually reduced the nursery irrigation to stimulate natural dormancy for the native perennial species that we used. Again, there were a couple of reasons for this as well. First of which was just ease and logistics. The drier plant material was a lot easier on our bodies and our equipment in moving it from our nursery site to the slope. Even though the nursery was close to the restoration sites, we were still putting that material into a trailer and driving it over there. And as you can imagine, this much plant material is going to be heavy regardless. The second of which is that we really wanted the plants to mimic the natural cycle and to give them the opportunity to break dormancy when they were planted in the restoration site. In that way, we could maximize the amount of time that the native plants got in the restoration site, in the soil, developing those deep, healthy root systems through the natural, cool, wet winter. We were also diligent about tracking how much of each of the 4 clonal meadow species that we used went into the slope and being intentional about making sure that they were relatively evenly dispersed across the 2 habitat transition zones. So we knew roughly what we were planting where for the most part, even though that plant material was going to get driven over by a tractor. I included this photo of my team holding holding sod material. I'm not trying to anthropomorphize the plant material. We know that they're not babies, though they are precious. But more so, I wanted to show just how dense the sod material is with rhizomatous plant material. If you look at this, that's just a massive load of plants of those perennial native species. I think in this photo, we are looking at creeping wild rye, which is a common transition zone grass species. So we brought that plant material in sod form out to the slope, and we laid it out, again, ensuring that of the 4 clonal meadow species, they were relatively evenly dispersed across the slope. We had an incredible partner in the work that we were doing out there in a farmer named Frank Imhoff and his son. He was very sensitive to the particularities of the work that we were doing and the process that we were trying to undertake. And then on top of that, he was just very interested and really curious about the restoration work that was happening as part of the U.S. Fish and Wildlife Service. We couldn't have done the work that we did without his expertise and help. And he was just a lot of fun to spend time with as well out on the slope. And so after laying out the disked material, the material to be disked, the tractor followed behind and disked that material into the slope. After the tractor passed through, we then had staff and volunteers follow and do a little bit of quality control work, making sure that in the disking process, much of that sod material was as underground as possible. So We did a little bit of manual burying of some pieces that were sticking up, but not very much actually. The disking worked pretty well to the eye. And one thing that's absolutely worth noting about this process is that of the first of the two HTZs, the Bedwell Bayfront levee, this is the one I have great numbers on. We disked sod material into the slope that was equivalent to 72,000 container plants of what we would grow in our nursery. For most of our community-based restoration and our smaller scale work, we grow our native plants in a traditional container plant nursery, and we use a particular type of nursery pot that's pretty compact and small, but allows the plant to grow a pretty deep and healthy root. We're able to grow as many plants as possible by using these nice compact and like very intentional pots. But we can't get anywhere close to the number of 72,000. This amount of plant material would not be possible for us to grow in our two container plant nurseries. And similarly, 72,000 plants would take our staff and volunteer programs 2 full planting seasons to outplant into the slope. So yes, there was some preparation to getting the plant material out of the division beds, putting it in that trailer and moving it out to the slope, but it got disked into the slope in one day. So in some ways, you could say that we planted 72,000 plants in one day using this mechanized planting method. It's just much more rapid than like what we had seen in the past doing that container hand planting with volunteers. This is a more expansive view of the second of the two habitat transition zone levees. This is the All-American Canal. It gives you a good picture of what it looked like when it was finished being constructed and that it was like essentially bare. And this is what that sod disking looked like. So the fluffy looking clumps we're seeing on the ground, that's that sod material that we pulled out of the native plant nursery. Another thing to note about the All-American Canal and this site is that we had another incredible partner in the San Jose Conservation Corps. They were invaluable at getting that sod prepared, getting it moved out to the slope, and then following behind and doing that quality control work that was so necessary in making sure that when we left the site, the plant material had the best chance of survival possible. After disking the clonal meadow species sod into the slope, and again, prior to the onset of rain, we seeded an annual cover crop across the site. We have found that if we sow native annual seed or disperse it across a restoration site later in the season, it frequently cannot keep up with the already germinated non-native or invasive species that are on those sites. And then it's not able to take up the real estate or grow as large or healthy as it does if we plant it, if we disperse it earlier in the season. So here we're looking at 2 images of the Bedwell Bayfront Habitat Transition Zone. On the left are our staff and volunteers hand dispersing that seed across the slope, walking back and forth, making sure that it's spread as evenly as possible. And on the right is that seed mix popping up in the first spring after being dispersed across the Bedwell Bayfront levee. So in the foreground, we're looking at Amsynchia or fiddleneck, which is, again, a common spring native annual. We dispersed about 105 pounds of annual seed mix across that Bedwell Bayfront HTZ. If you're a restoration practitioner and you've done any revegetation efforts, 105 pounds might seem like a pretty low weight compared to what might one use on a hydroseeding project. And that is true. It is. One thing that's a little different about this seed mix is that the seed was all locally collected by staff and volunteers and also cleaned in our nurseries. So there's, they are species that we know were growing in the area or were collected close by. Another tool that we employed in increasing that weight as much as possible is we brought some of our collected seed to a local seed grower, in this case, one called Hedgerow Farms and Winters, and they grew out our collected native seed, essentially amplifying it and cleaned it through an industrial process with much bigger tools than our volunteers' hands and handheld sieves. And so we were able to increase the bulk that way. It was very effective. We got a lot of like beautiful pure seed. In this case, we used them to grow out some tar weeds. It was also very expensive. So pros and cons. Um, Next, we hand planted the diversity patch species. This was these species similarly were grown at our on-site division bed and in sod form, but they were not included in the mechanized planting process, either because they were less stress tolerant species or because they were less abundant in our propagation. However, they did provide vital additional ecosystem services like pollinator resources, biodiversity, um, and this plant list included some common and well-known species like yarrow, mugwort, and marsh baccharis. So you can see in this photo here, we have volunteers and staff hand planting that sod material directly into the slope. A little bit of numbers there too. We hand planted around 3,800 sod pieces, which looking at our math from a container plant nursery standpoint, that's about equivalent to 15,000 container grown nursery plants too. So again, like a pretty big number compared if using this sod method. Our final functional group were the refuge patch species. These species were intended to provide dense, shrubby high tide refugia adjacent to tidal marsh channels. Amongst others, that species list included marsh gum plant and some lightly salt tolerant shrubs like California rose and California blackberry. Most of these species were actually grown in containers in our container plant nurseries. Many of them are not rhizomatous, and so there was less benefit in putting them into a division bed to amplify and grow out. And, growing them in containers made this outplanting effort a little bit more volunteer friendly and accessible. And so we frequently invited the public in different programs to come out and join us in our efforts. And then, as you can imagine, it's it's like much more easily translatable to ask a volunteer to plant a plant that's growing in a pot than to hand them like a softball sized clod of dirt and roots and say, like, I promise you, this is living plant material. This will make it. Your efforts are worthwhile. We appreciate you. And so when it came to like staffing those programs, this type of work is a little bit easier to do with members of the public than some of the like wild new methods we were trying. And again, we planted about 8,700 individual container plants as part of the diversity or the refuge patch functional group across our 2 planting seasons at the Bedwell Bayfront and Habitat Transition Zone. So to give you an idea of like what the ratios of each different functional group looked like. It was a little bit less for this one, a little more like intentional and targeted planting adjacent to those tidal marsh channels. We did rely more heavily on volunteers during our public, corporate, and community programs to help us in our invasive and non-native species management. We did this mostly to provide more support to the native species that we had outplanted and to make sure that some of these plants that are highly competitive weren't taking up space or resources that we wanted our native species to get. This is another place where our partnership with the San Jose Conservation Corps was instrumental. They contributed significantly to our maintenance efforts. Over the course of the project at the 2 habitat transition zones and also at the on-site division bed nursery, we've engaged around 1,200 volunteers in our efforts, and we've removed a whopping 41,000 pounds of invasive species from the project. This photo here is one of, I think, the Conservation Corps and our staff pulling out Russian thistle. That's pretty hefty, a pretty hefty plant. We have filled up this trailer many times. It's like an instrumental tool in moving or getting close to that 41,000 pound weight of weeds. These numbers also don't include any additional hours that our volunteers contributed at our container plant nurseries, helping clean seed, propagate plants, or anything else that is related to our lofty project goals here. So though our team believed that this mechanized method was feasible, the Ravenswood complex is the first time where we were able to actually try it in the field. And we wanted to know if the 4 clonal meadow species that were distant to the slope could survive and become established. So one of our team members developed a clever population census method to estimate the presence of clonal meadow species. We planted in the fall and we conducted this monitoring in the spring. This was a feasible time of year because the plantings, the annual seed, and the non-native annuals had germinated, but were small. And so we chose a time when the clonal meadow species had broken dormancy, were putting out new growth, and were easily identifiable. To do this, we diligently walked the slope and we noted each instance of the clonal meadow species that we saw. So the percentages you see here indicate the total individuals seen in that population census compared to the number of sod pieces that we knew we had dissed into the slope. Is this method imperfect? Yes, probably. Is it anecdotal? It might be anecdotal. Did the disking break the sod into so many pieces that they were dispersed across the slope? Probably, and that's also something that we wanted to see. And so to account for that, plants were counted as individuals if they were more than 18 inches apart. That number was decided upon because that's how large the pieces of sod that we were putting out were. So that's why you'll see percentages above 100% for ragweed and for creeping wild rye. This method didn't give us any information about the percent of native cover across the slope, but it did give us an idea if this brand new to us method of disking was successful in establishing the 4 clonal meadow species, and if they were able to survive the process and successfully put out new growth and live through that first winter. Save the Bay's regular annual monitoring process uses a protocol developed to monitor the plant community structure of intertidal upland ecotone. We do random quadrat sampling conducted within 4 strata, which are the planting zones based on slope gradient and within our restoration sites. In this protocol, we look at plant community structure by assessing the percentage of bare ground that's covered by individual species or by bare ground. We conduct this monitoring protocol every year in the late summer at several sites around the bay. And so these are some of our overview of our results from monitoring the Bedwell Bayfront habitat restoration zone. We chose this one because we have 3 years looking at that site as opposed to the newer All-American Canal. Keep in mind that as you look at this, that the levee was breached in December of 2023, and that might have changed the composition of the 4 strata or the elevation between the years of 2022 and 2024 and that monitoring. I'll also note that we didn't have baseline data from the Bedwell Bayfront Habitat Transition Zone. So our monitoring results in 2022 happened after our first year of planting in the fall of 2021. So in total, the native species cover average increased from 6.7% to 7.8%. The non-native species cover decreased from 28% to 21.5%. And the abiotic cover increased from 65.8 to 72.3. Briefly, and a couple of things worth noting about the native plant cover. Across the 2 lower strata, we saw an increase in some of the low marsh and intertidal species, some of which we did not plant and included species like pickleweed and fleshy jaumea. It's possible that the seed bank for these species may have been carried in through the tide post-breach. There was a significant decrease in some of the annual seed mix species that we know are less tolerant of tidal inundation, namely tarweeds. Many of these species do exist in transition zone around the bay, but they might be less tolerant of tidal inundation and prefer drier conditions. We did see an increase in cover of all of the clonal meadow species except for saltgrass. So that's 3 out of the 4. Ideally, when we look at the longer term composition of this site, annual species should function as a placeholder, taking up space while the perennial rhizomatous species form more dense colonies and eventually push them out. The numbers do indicate that, though it is pretty early in the restoration. In the mid and high strata for non-native species cover, We saw a marked decrease in species that were actively weeded by volunteers and staff, including European mustard, Russian thistle, and sweet clover. We were happy to see that that effort was reflected in the data collected, and that we were knocking down some of our common invasive species that we were targeting because we were concerned about their ability to push out the native plantings. Abiotic cover for our purposes includes fine material and coarse material. Fine material being sediment and tidal marsh mud, coarse being driftwood, rocks larger than a pebble, plant material, etc. We saw some increases in abiotic cover. They may have been related to the breach and the tide coming into the bay. The breach occurred after we monitored in 2023, so in between the data we collected in 2023 and in 2024. I just wanted to collect a couple of lessons learned from our work here. We tried so many novel methods on these two habitat transition zones, and we learned a lot that we hope to share with our community of restoration practitioners, planners, partners, and any interested parties. I'm happy to be here giving this presentation because I think there's a lot to learn, and I think, you know, the title of the presentation was Trial and Tractor. These two restoration sites really did feel like a trial for us in many ways, but I think we were generally excited with what we learned and what came out of it. The mechanized disking planting method that we tried at Ravenswood is something that we have talked about and dreamed about doing for years, and we're finally able to do it at Ravenswood. Yes, I have dreamed about driving a tractor on a habitat transition zone. So I wanted to bring together a couple of critical takeaways for that work, including the importance of an on-site division bed nursery. This was an incredible tool in reducing travel between our nursery sites and our restoration site. Additionally, the nursery's connection to a municipal water line was excellent in that it reduced the amount of water that we were using on the site, and it reduced how much we needed staff to be at the nursery, watering, committing that time. It created flexibility where we could be doing other things and we could know that our plants were getting irrigated and that they were amplifying in the division beds. If I were to do it again, I might consider restructuring the nursery so that one could drive maybe a small mini excavator or something in between the beds. This could create the option of using heavy equipment to pull sod out of the beds instead of relying entirely on shovels and human bodies, thereby reducing labor even further. And because we've kept this nursery site alive and active for many years, these perennial native species are not only good at colonizing restoration sites, they also love to break free of division beds. And so there's an element of maintenance that needs to happen moving forward if one intends to keep a division bed nursery like this alive, functional, and aesthetically pleasing. And so I'd recommend heavy weed cloth and a unintentional maintenance schedule if keeping a nursery like this around for more than a couple of years. The native rhizomatous species that we included in the plant list proved to be productive, hardy, and successful. We were able to collect significantly less plant material from wild populations, plant it in the division beds, and then allow it to amplify over time. Over the course of a year and a half, those division beds were full of dense rhizomatous sod material. This is great for reducing labor on staff and pulling plant material from the field. It also reduces the stress on wild populations so that we are impacting them as little as possible. On the flip side of that, we found the annual seed mix collection to be pretty challenging. There are not necessarily source populations big enough to build up a hyper-local seed mix for a project of this size. So moving forward, I would consider where it's appropriate to purchase seed from a local seed purveyor, if something like an amplification, like a contract grow were possible, or where we could reduce the number of species included in a seed mix and be more intentional that way. The mechanized methods, especially when timed well, proved to be successful to us. We found that stimulating the natural dormancy of these perennial species was really helpful, not just in reducing the labor of moving it, translocating it from the nursery to the slope, but also in timing the break in natural dormancy with the natural cycle of rain. These large sod pieces proved to be pretty resilient and drought tolerant in that interim time between planting and when the rain did start in earnest. This was a very laborious method, but it was quick. Like I said, the disking of the first of the two HTZs took only 1 day and was equivalent to us hand planting about 72,000 container plants. There was a little bit of uncertainty for our staff around the breach. It was challenging for us to correctly estimate the mean high tide line when planting the habitat transition zone prior to the breach. We had estimated that elevation based on an adjacent mature marsh, and that proved to be inexact in a couple of places. And so we did expect a loss of plant life, especially in the lower strata. And we did see a little bit of that. I think with the second of the two habitat transition zones, we were very intentional in like thinking about where we would plant those lower marsh species so that we could guarantee as much success and survivorship as possible from them. Volunteer engagement and access similarly gave us a little bit of heartache at times. Not to bring it up, but COVID happened in the middle of our planning process for the first of the two projects. I know we hate to think back to that time, what a time it was. There was our first year of planting the first of the two habitat transition zones. We actually were not able to bring volunteers out to the slope. And so our plans of sharing that labor and effort and educating the public about the importance of tidal marsh habitat and the South Bay Salt Pond Restoration Project, it was a little delayed. We also frequently have needed to cancel volunteer programs depending on weather to provide more safety for staff and volunteers and to make sure that we're not doing any damage to the levee tops. Many habitat transition zone levees are accessible only via levee top roads. And so that was something we needed to consider when scheduling our winter volunteer programs. One thing we had to rely on and feel good about is that we had done the bulk of our revegetation in the fall prior to the rain. So even if we weren't able to access the slopes and get out there, we knew that we had a lot of nice little plants that were enjoying the rain and developing those nice healthy root systems, and that when it did dry out, we could come back and do more of that diversity planting. But we were not lost. We had done a lot already. Similarly, our weeding season could be limited on these two sites, especially the All-American Canal, due to western snowy plover nesting. So we know to get as much weeding done as early in the spring as possible. And our team also prayed for a cool and wet spring, which we know can sometimes slightly delay the onset of nesting season and provides that additional benefit of helping the native plantings develop those healthy root systems that can carry through our very dry Mediterranean summers. I want to thank our many partners on this project, including the organizations and agencies whose logos I've compiled here, and also individuals like Frank Imhoff and Peter Bay, whose expertise was instrumental in helping us get this revegetation effort done. And obviously, thanks to my incredibly hardworking team and to Hamar Lim, one of our staffers who provided many of the photos that I've included in this presentation today. And so thank you also for everybody for listening to me talk about this project. If you're interested in learning more about it and you like to learn through getting your hands dirty, I would recommend that you come and join us out on one of our public volunteer programs. We have a calendar of those activities that is updated very frequently on our website here.
Great. Thanks, Jessie. Fantastic presentation. Really fun to see all the work that you guys have done. I think they do already have one question for you. See, Anne Morkill. Welcome, Anne. It's great to see you. She says from the photos, it looks like you're able to start with a clean slate with new soil and fill. Would you expect similar results for a fallow ag field that's already been colonized, but could be disked before planting or seeding? And great work.
Yeah, thanks, Anne. It is a gift to start with a clean slate with new fill and soil. We have done some work in other sites around the bay where we were working in fallow ag fields that had already had like a pretty extensive non-native and invasive seed bank. It is much more effort. I think if we were to do something like this again at a site that was not a clean slate, we would think about employing somebody to disc or maybe mow the site beforehand, which might reduce the amount of non-native cover. If you're starting with a site that already has an invasive seed bank, it is much more of an uphill battle regardless. So perhaps I would not expect similar results. Hopefully it would be a site where we could really employ a lot of volunteers and um, put an earnest effort into that invasive species removal.
And did you want to follow up? You guys you feel free to unmute if you have additional questions or want to ask your own question too.
No, thank you very much. I kind of expected that answer, and it's something we'll be dealing with a relatively large project up here in freshwater marsh. But love to see the progress on this project, having worked there for several years. Great job.
Great.
Yeah.
John Calloway, do you want to ask your question? Otherwise, I can share it. So where is it? I just lost it. I think John was curious about if you have any thoughts about why Disticless didn't do as well.
Yeah, I do actually. We have done similar large scale work at Eden Landing, not employing the mechanized planting method, but doing a lot of bulk rhizomatous clonal meadow species planting. And have found with Disticlus at that site, again, this is like anecdotal, that it's a little bit slower, like that it's just slower to grow in than things like creeping wild rye. So I would guess that when we monitor the site this coming summer, that we would probably see a higher percent cover of Disclus than we have in the past. Yeah, similarly, it is weedy, resilient, and also very drought tolerant. So it was a little surprising to see it not taking up as much cover as the other species.
And some kudos from John Krause saying great talk and thanks for all the work that Save the Bay and the community has done at Eden Landing all these years and across the bay.
Yeah, thanks, John. Our staff love working at Eden Landing and they love running volunteer programs out there. We're always looking for more opportunities to work at Eden Landing. Beautiful site, and thank you for all your work managing it for so long.
Dave has a question. He's curious about the increase in abiotic cover. And was it from dead plants dying or from tidal water coverage or something else?
Yeah, I can't say specifically. I think it was from tidal water coverage and from plant death. There were a couple of areas across the Bedwell Bayfront habitat transition zone where the tide came up a little bit higher than we anticipated. So some plants did die because of tidal inundation and their particular preferences for how much bay water they can tolerate. I think what we will probably see as we continue monitoring the Bedwell Bayfront levee is that the lower tidal strata, intertidal and low in particular, will probably come up higher in elevation across that habitat transition zone than we had originally thought they might. But it's sort of tough to say right now.
Dave, do you want to add anything else? And any other questions from folks for Jessie? Jessie, maybe you can tell us a bit what a volunteer day looks like and how long your programs are.
Great. Like this project, our volunteer programs are pretty seasonal. So where we are right now is we're doing a lot of weeding at our restoration sites, and we're also doing a lot of native plant propagation at our nurseries. So our volunteer programs happen at several sites throughout the bay and also at the container plant nurseries. We try to provide opportunities for folks in different parts of the bay. We don't work everywhere, but we do work geographically in a couple of different sites. Our programs are about 3 hours long. They include a break, some snacks, some like very excellent scene setting from our environmental educators. Our staff is really fantastic at guiding people in the work that we do, letting them know how it fits into the bigger picture, making sure that people know where they are, because frequently we have volunteers that are not as familiar with our tidal marsh and shoreline sites, especially with some of our corporate programs. People move to the bay, they're entirely new to the bay. All they know about tidal marsh is that they drive over the 84 and sometimes it's stinky to them. So it's a good opportunity to make sure that people know why the work we do is important, and so that when they vote or when they think about how to spend their volunteer time, that they're thinking about the sites that are important to so many people that are here in this room with us. So it's physically active, it's engaging, and it's brief enough where you'll probably leave sore, but it will not wipe you out for the rest of the day.
Thanks for that.
Uh-huh.
No, just trying to get you some volunteers for more of this work. That's great.
It's also so fun. It's just so fun getting out.
Any other questions from folks? If not, I just posting in just as well, you think about whether you have any other questions. I just posted in our upcoming schedule for this speaker series. Next month, Christina Toms from the Water Board and I will be talking about both the WRMP and how that overlaps, how that work is overlapping with some of the monitoring work that we're doing for the South Bay Salt Pond Restoration Project. And you can see some of these others. The schedule could shift. There's a lot of change happening within federal government staff right now. So, but this is what we're anticipating for the coming fall. So just wanted to share that. And then if you want to, Jessie's talk today will be recorded. So if you want to share that with someone else, or you want to view past recordings, there's also a link in that chat for some of the past events that we've had, which have been really great. This series has been really fun, just to learn about all the work that people are doing on that relate to our project. So other thoughts or comments or questions? If not, we may be done a little early today. I just want to thank everyone who's been coming to these. These are it's really great to see the questions and interest in this work.
And maybe I'll just voice a big thank you to the Save the Bay team and Jessie and some of the volunteers. Martin's here today and probably a few others. I haven't scrolled through the list, but I just, we are asked all the time. I do a lot of stuff with the public and media and everyone else. They all want to know how the plants get there, right? And we always talk about, well, the lowest elevation, the pond bottom, the tides carry that stuff in, but all around the perimeter, that's all our nonprofit partners and their volunteers. And it's just super important for how it all happens and works and how it looks and functions ecologically when we're done with the work. So I just want to thank you all again for that hard work. And I'm just sorry that we don't have more money for water trucks and more land for seed banks, right, to help grow these things and get them established more. So if people want to, sort of make a big difference, like water trucks would be great. Get these things going, right? Help compete the weeds.
I know. Yeah, there's infinite opportunity for funding and infinite opportunity for folks to come out and help us do the work. They're big sites, we appreciate people volunteering their time, and we appreciate partners that help us get this work done too. So thanks to the South Bay Salt Pond Restoration Project and Dave and Donna for letting me speak about our work, and you know where to reach me, folks. Do you have more questions?
Well, I'll go ahead and end the meeting then for us all. And thank you all for coming. And thank you, Jessie.
Thanks so much.
Thanks, everyone.
Bye.